Good morning, sir. Good morning, sir.
Hello. Yeah, good morning, Ananya. Am I audible now?
Yes, sir.
Okay. Have you solved, like yesterday, did you try some problem?
Yes, sir. I had a few doubts. Where can I post them, sir?
Okay, yeah, you can try to share those problems, yeah.
Um, Sir, where can I post them? Like WhatsApp or
In chat section, you can upload.
okay, okay. So, one second. Sir, I've sent one of the questions, sir.
Okay. In chat section, there's no question yet.
Okay.
Then I can share my screen. Hmm. Okay, you can share those to the Manisha ma'am.
Okay, sir.
Share to Manisha, she will share it to me.
Sir, otherwise we can start with matrices, sir. Like, and then we can later when I figure out how to upload them in chat, I'll share them, sir.
Okay, so we can start with matrices, is it?
Yes, sir. Yes, sir.
Okay. Relations and function is also there. Matrices. Yes, okay, look, one chapter is also there just after the followed up chapter by sets. Okay,
Okay,
that
sir.
is relations and functions. I think it's an easy chapter. If you try, you will get it. If you like read some NCRT or some book, now you will get to know about this chapter. You
Okay.
don't have to put much effort on this chapter. Okay. So, what is matrix? Matrix is basically an ordered rectangular array which have collection of numbers. Okay, or you can say function which are arranged in row and column. Okay,
Mhm.
so that's called matrix. What is it? A rectangular array consists of numbers and functions which which is arranged in rows and columns is called as matrix. Okay, so this is the definition of it. Whatever when we put some numbers or functions, we call them as entries. Okay, so the numbers and functions present inside as elements are called entries. Just a simple example we can take how we represent the matrix. Let's say I'm calling this matrix as M. Okay, a bracket and put whatever you want inside. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I have given us 3. Let's add one more 10, 11, and 12. If you see it carefully, we have something called rows and columns. What is rows? If I go in this way, this is row. Okay, row 1, row 2, row 3. Okay, and if I go something like this is column 1, column 2, column 3. Okay, and here is you have column 4. Understood? So
Yes.
how we represent this is we represent it in the form of row and column. Any doubt?
No, sir. Clear, sir.
It must be clear. Okay. So something we called how we represent actually the matrix in which form. So we represent it in the form of what I can say like how many columns are there and we multiply it using. Okay, let's all right. So if you see how many rows we have in this case, in the given case, how many rows we have?
We have three, sir.
Three, and how many columns we have?
Four, sir.
Four. So how we can represent like what should be the order of matrix?
Um, According to sequence,
What is dimension? Basically, we call dimension as your raw number of rows. I can also write this as number of row into number of column. Clear? So in this case, if I ask what is the dimension of it,
it's 3 into 4.
just a second. Okay. Okay. Yeah. So here we have row and column as 3 into 4. Clear? This is how we can represent it. Fine. Let's move next and check something. Okay. So this is basics of your matrix, right?
Yes, sir.
Now, if you see raw and column, raw is basically your horizontal arrangement. If I have to give the definition to this, horizontal arrangement. And what is a column? A
Vertical.
vertical arrangement, right, of entries. Okay, of entries. These entries can be anything like numbers, functions, alphabets, like whatever I want to I put in my matrices. Okay, that's fine. Now, what is order of matrix? It basically tells us the number of rows and columns of a matrix. Order it tells number of rows and columns in matrix. Okay, I hope everything is clear till now. If you have any doubt, you can let me know. Okay,
No, sir, all clear, sir.
all clear. Okay. Now we will discuss some types of metrics. Types of metrics. So, what are some types of metrics? I'll be starting with first calling as raw metrics. What did you understand by just this term? I'm not writing further. Raw metrics. What you can interpret by this?
So it has one row.
It has one raw. If you see, it is raw matrix. Mean to say, this matrix will only contain raws, right? So if I say something like this, matrix containing only raw, only raw. Okay, it means there will be matrix called A, and it will be looking like this. The entries can be A, B, C, so on. Now, if you see, you have one row, two row, three row, right? But if you see, there's a default one column, right?
Yes,
This one column will be default because look, if you increase columns, let's say one, two, three, so it has two columns also. In that case, you can't say it is a raw matrix. Okay, for raw matrix, your column should be one. If I say column matrix, your raw should be one, right? So if I ask you what is order of it, so what it will be?
it will be
Remove this.
3 into 1.
It is 3 into 1, right? Okay. So next come up is column matrix. Column matrix. This is basically again matrix containing columns, having only columns. For example, we can just put some random matrix. Again, here you'll be having A, B, C, D, E. Okay, and order what comes out, whatever you have. Let's say
1
one into n times of numbers. Clear?
is sir.
Basically the size. That's all. Okay. So after this row and column, we have a kind of square matrix. What does this square matrix mean?
Definite number of columns and rows.
Yeah, equal number of columns and rows. Okay, equal number of rows and columns. Okay. So the matrix is there. You have A, B, C, D, E, F, G, H, I. You can see 3 into 3. Okay. Just after this base, we can represent this matrix size also like this. Okay. Complete this and you can write it like this. 3 into 3. You can see rows and columns are same, so we can see it's a square matrix.
Yes, sir.
Okay. Next one is we have diagonal matrix. What do you think? What could be the diagonal matrix?
Not sure, sir.
If you see all the metrics whatever we have written now, they're like simple a little bit. Like if you just go through the names, you can understand what kind of metrics I'm going to represent. Okay, so when I told I'm going to make a raw matrix, mean to say I'll be having elements in raw, in column. In case of square, I'll be having elements in the, what I can say, square representation. So what it meant by diagonal means to say all the elements should be presenting diagonal only. Entries presenting diagonal only. Now, if you see, if I write, let's say one, two, three, what does this mean? Should the rest of the part should be like empty? No, there's nothing like that. Mainly, what we do in matrix, we put numbers. Okay, it means the rest part should come out to be zero. Understood?
Yes, sir.
Apart from diagonal, rest of the elements or entries should be zero. If you see, it becomes what kind of matrix?
Diagonal. So
Diagonal.
would it still be called a type of square matrix only?
Yeah, exactly. It's also a type of square matrix. Okay,
Okay, sir.
square matrix. You can, okay. Now, if I ask you, if you see carefully, I have a square matrix, right?
Mm-hmm.
A square matrix contain all the squares possible, whatever square you can form, right?
Mm-hmm.
So, can I say one thing that it also contains diagonal matrix as subset,
Yes, sir.
right? So this is the thing. So I can say that the diagonal matrix are subset of your
Squares.
square matrices. Understood? All right. Now, next one comes up as scalar matrix. Okay. So a very simple, just difference is there, equality. If you see in diagonal matrix, what was the case? It was not necessary that all the diagonal elements were equal. Okay? They can be different, distinct. Okay. Here, what the thing is, a diagonal matrix having all diagonal entries to be equal. Okay,
Yes, sir.
it's a type of diagonal matrix, but it all the elements of the diagonal is need to be equal. For example, this 1 1 1 0 0 0 0 0 0. You can put it 4 also. Whatever you want, just the diagonal should be same. Diagonals need to be uh, same actually. You can say. Okay. The next some matrices are there which is important. This is called identity matrix. Okay, fifth and sixth matrix. Identity. It is very important because it is used too many times. Okay, identity matrix. Just the thing is, take the same matrix. In this case, what happens? All the diagonals just go as a one. That's it. Okay. The only difference. Understood? In diagonal, on elements present in only diagonal. Okay. In scalar, the diagonal element supposed to be equal. In identity matrix, all the diagonal elements supposed to be one. That's it.
So,
Any doubt? In
so is it kind of similar to like how we say unit vector in physics? Like,
exactly. If you see unit vector, right? Unit. When I say word unit, it means one.
yes.
Identity is also for the one itself. Okay.
Okay, sir. Got it.
Okay. Some more matrices are there. I'll just try to explain. Okay, if, I am calling one as zero matrix. What do you understand by that?
Every entry is zero?
Yeah, that's it. Okay, so I won't write that. We also call that as a null matrix. Understood?
Yes.
All right. The next one is rectangular matrix. Rectangular, right? We generally write any kind of matrix when you write, it comes into m into n, is it?
Yes, sir.
Okay, so look, when I say I want to create a rectangular matrix, so what I want? I want to make something rectangular shape, right? And how you can get a rectangular shape? Just any kind of any order you can take, m into n into m. You should also know one thing, that a rectangle is also kind of like a square is also kind of rectangle.
Yes.
Understood?
Yes, sir.
Okay. So yeah, that's the thing. The next one is horizontal matrix. Horizontal matrix. What do you think in that case?
Mm,
Just think of it horizontal. When how you will identify whether it is horizontal or not? When the height is lesser, right? If you see something like this, I can say it is horizontal. Is it?
I didn't understand, sir.
Didn't understand?
Okay, okay, yeah, I got it, sir. Yes, I got it.
Okay, horizontal. Okay. So if you see in horizontal, if I want to write, let's say this is one entry, one entry, one entry. Okay, basically in rows. If you can see one row, two rows, three rows. If I want to print columns, one, two, three. So you can see in horizontal, you need more columns, right?
Yes, sir.
So I can say when your rows, like when your rows are less than column, we can call it as
Correct.
horizontal matrix. Okay.
Yes, sir.
And vice versa for what kind of matrix?
Vertical matrix.
Vertical matrix. Okay. So I think this is clear. And the last important thing is unit matrix. The last one is unit matrix. Try to figure out what can be the unit matrix. What should be the characteristic of a unit matrix?
It has only one entry.
No, actually, all the
Already.
elements. Okay. Yeah. So basically, whatever the elements you have. Okay. So basically, all the elements. Okay. In the diagonal should be one.
Then it will be the same as identity matrix.
Exactly. It will be same as identity, but basically, one is there now. So the unit is used for the one. Clear? Just the definition goes a bit different. That's it. It's a kind of like it's same as identity itself.
Okay, sir.
Basically, if you see identity matrix, unit matrix, scalar matrix, all these were kind of a diagonal matrix itself, right? And you can say another case, all these were a kind of square matrix. Then you went to the diagonal, and then you went to the scalar and identity. Understood?
Yes, sir.
Okay. The next come up is equality of matrix.
So there is no difference between identity matrix and unit matrix.
Exactly, there's no difference. Okay, just naming is different. That's it.
Okay.
Nothing apart from that. Okay, the next one which we come up as, that is equality of matrix. Okay. Equality of matrix. When we can say that matrices are equal or not? Two matrices are equal if only if order of both matrix are equal and elements of one matrix is equals to another one at corresponding places. Is it clear?
Yes, sir.
For example, I have one matrix is A, 1, 2, 3, 4, and B I have is 1, 2, 3. I can say both are equal, okay? But if I have B as B dash, let's call it as C. Okay, it will be better. Let's call it as C. C. C is like 1, 2, 3, 4. So if you see they are not equal, okay? What you have to check? First, you have to check the order. 2 into 2, okay? 2 into 2. Order is correct. I can move to the elements. Equal, 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 equal. That's fine. Okay. Let's compare with this one. 2 into 2. Okay. Order is same. Now I can move to the elements. 1, 1, 2, 2, incorrect. It is not equal. Okay. You have to check order and each element present at corresponding place. Then you can say it is equal or not. Understood?
Yes, we got it.
Now we come up with operations in the matrix. Okay, this is the most important part. If you understand the operations and all, we can move to the I think problem solving part.
Yes, sir.
Operations in matrices. Okay, just a very simple idea I'm giving. If you see two matrices A and B, what operations you can perform in between these two?
We can add the elements, we subtract the elements.
Look, what you can do. You can add two matrices. Is it?
I think it's a question.
You can do addition of the matrices. Operations mean to say what I can do with the two given matrices, right?
Yes, sir.
Okay. So first idea is I have to add two matrices, but there should be some condition. Like I'm giving you some example. I have one matrix is this one, two, three, four, five, six. Another matrix is like this one, two, five, six, seven, eight. Can I add these two matrices?
No.
Right? How I can add when the order is same. Okay, why order is same? So that I'll be having corresponding elements also. For example, for one I have this one, for two I have this two, for three I have this six, for four I have this six to add. But what about this five? I don't have any other five present, like any other element present here. I don't have any other elements present here to add. I don't have any this element present here. I don't have any this element present here. Understood this thing?
Yes, yes.
So to add two matrices, what is the most important thing?
Order should be the same.
Addition. Okay. Order of matrices should be the same. Should be same. So let's say this is A given as 1, 2, 4, 5, B 2, 9, 11, 12. So what is the sum? A plus B?
Would be
Okay.
11.
3, 11, 50, and it will be your 17. Clear? If I ask you what is B plus A, again it will be 3, 11, 15, 17. Clear?
Yes, sir.
So I can also say one thing that A plus B, when it comes to matrix, A plus B is equals to B plus A. Clear?
Yes, sir.
Let's come to next thing. What is that? Multiplication of the matrix. We can call multiplication of the matrix. This part you have to understand a little bit carefully. So this is multiplication. Okay. What we are going to do in the multiplication, we have to multiply. But how we can multiply? That is the condition. Okay. So I am given here is, let's say two matrix, matrix A, matrix B. I have to multiply. So how we can do this? In this, first we have scalar multiplication. Okay. In scalar multiplication, what we do is we keep a matrix A, and if I want to multiply, scalar mean to say I'm going to multiply the some number, for example K. So whatever I am going to get, for example, A had some element as remove it. Let's say A was what I get say one, two, three, four. Okay. So what will be the K multiplied by A? It will become K, 2K, 3K, 4K. Is this clear?
Yes, sir.
You just have to multiply all the elements whatever you have given outside. Okay. So I can also say you can take this K outside. If you want, you can take this K outside also. So if it is written like this, one, two, three, K, it four. It means you can multiply it this thing with each of the element. Clear?
Yes, yes, yes.
Whatever present in this. So this is what a scalar multiplication looks like. Okay, the next one is just a second. Okay, the next one is negative of a matrix. Okay, so can you tell what could be the negative of matrix?
You should change the signs of all the.
Exactly. When okay, you just change. You just have to reverse the sign. Okay, sign convention. If it is minus one inside the matrix, you can put it as that will be give you a negative of a matrix.
Yes, sir.
Okay. Then we come up as difference of a matrix. What could be that?
So same thing. Order, if the order is same, you have to subtract the elements from.
Yeah. Okay. Subtract. Okay. Difference. A minus B. So what do you think in this case? Will A minus B will equals to B minus A?
Not necessarily.
Not necessary, right? It will only possible if entries are going to zero.
Yes, sir.
Like if A minus B comes zero, then only it is possible, or else it is not possible.
Yes.
Because, for example, if A is greater than B, so whatever you are going to get will be positive. But if you do B minus A in this case, what you are going to get negative. Is that
Negative.
clear? So yeah, that's the thing. You will get this condition only if and if A and A minus B is equal. Okay, I'm removing the difference part because it's an easy thing. Now look, we did some addition. Okay, matrix addition we already did, addition of matrices and all. Now we will discuss some properties of matrix addition. Okay, so what are properties of matrix addition? First of all, you already seen this property, right?
Yes, sir. Commutative property.
Yeah, we call it as commutative property. Property, and you can say commutative. Okay, the next one we can come up with the associative. What is associative? Associative means to say I'll be having three elements. I can associate. Okay. For example, this. So I can say one is equals to A plus B plus C. Okay. Associative one. Any doubt you have?
No, sir. Clear, sir.
Okay. Um, Inverse matrix, existence of additive inverse. Additive inverse mean to say
The sum should be zero.
what?
So the addition would be zero of the two
Yeah,
matrices.
exactly. So like this is one matrix. A plus minus A should come out to be zero. Okay.
Yes, sir.
You can also say it is equals to minus A plus A is equals to 0. This is what kind of thing? Existence of additive inverse, or you can directly write it as additive inverse. Okay. Now the next part is multiplication of matrices. Okay, if you see carefully, we did here. I just told you scalar multiplication, right?
Yes, sir.
I didn't told you how you can multiply two matrices. So what we do is, in case of multiplication of matrices, we multiply two matrices A and B, where number of columns of A should be equals to number of rows in B. Okay.
Yes, sir.
Matrix multiplication. Okay, how we do matrix multiplication? If I am having A, okay, let's say 1, 2, 3, 4, 5, 6, and if I am having a B, another, I'll be doing it like 3, 4, 5, 6, 7, 8, 9, 10. Okay. For first element, I'll be having something A into B. Okay, I'll be having this as A into B, some bigger thing. So how we will start? We will take this element first, multiply it with the first. What you got? 3. Then take this, multiply it with this. What you got? 8. Add both. This will gives you one element. Is that clear?
Yes, sir.
Okay. Multiply first row with first column to get first element. Okay. Take this row, multiply it with second column to get another row. This, if you do, you will get this one. Understood? This is how you have to do.
Yes, sir.
Okay. Now, if you see carefully, when I am multiplying my raw with any column, if you see, I have add right after each like one to this, one to this. So if you see, I need this number of raw of the first column, number of the column in the first element, let's say whatever it is C, should be equals to number of rows. Is it?
Um, yes, sir.
Okay. Look, what I told, you have to take first column and have to multiply it with the first row to get your first element.
Sir,
You can call it C1.
first, first
Yeah.
row and the first column, right?
Yeah. No, no, wait. Take for the first matrix, you have to take first column. Okay. And here you have to take the first row. Uh,
Sir, is it, you're saying
wait,
it
wait, wait. I'm just, let's go to see. All right. So look, what I'm saying is, you have to take the okay, this is raw. Yeah, first raw multiplied with the first column to get the first element. Understood?
yes, sir, got it.
Okay. At each operation, you have to multiply, then add with the next operation of the same element. Understood? So let's solve this one also. Then we will see what's the problem and how much final we are going to get. First, take this part C1. So 1 into 3,
3,
3, right? Plus 4, 8. This is the first element you got. Now do this with this. You'll be getting 5 plus 12.
12.
Another element you are going to get is this is 1, right? So 1 plus 16. The next one was what is this? 1 plus I think 9 plus
That's 9,
10.
sir.
Okay, 2 into 10, 20. Okay, this is the one thing. Now I went to this. If you see what I'm going to get,
9
9
plus
plus 16.
16,
I'm going to get 15 plus 24.
24.
I'm going to get 3 plus 24. I'm going to get 27 plus 40. Understood? And the last is 15 plus again 24. Yeah, I had another also. Okay. 25 plus 36. 5 plus 40. 45 plus how much? 60. Is
Sir,
that clear?
5, sir, 5 plus 48, sir.
Okay, 6. Yeah, 48. 40. Okay.
And 3 plus, like above that, 3 plus 32, right? Uh,
32. Okay, 4. Yeah, 30. 30. It should be 30.
yes, sir, got it.
If you see what is my final order, it comes out as 3 rows into 4 columns. Is it?
Yes, sir.
Okay, let's see this part also. It has 3 rows into 2 columns. It has 2 rows into 3 columns. Is it? Like
Yes,
4 columns. So
for
if you see, I told you to have like for the possibility of multiplication, rows of the first matrix should be equals to columns of the second matrix.
hmm.
No, no, wait. Columns of the first matrix should be equals to rows of the second matrix. Is that clear?
Yes, sir.
And the rest, whatever you are left with, rows of the first multiplied with the column of the second will give you the final matrix result. Understood?
Yes, sir.
Makes sense? So I can say that if A is having m into n, then B must be uh, then B must be n into something. Okay, n into say this and this should be equal. Is that clear?
Yes, sir.
Then you can do. So it will result A into B of how much? M into K. Understood?
Yes, sir.
Okay. Any doubt you have?
No, sir, clear, sir.
Okay, I'm giving you an example. Let me know the answer for this. A equals to 2112. B equals to 021111. Okay, yeah, solve this one and let me know the final answer. What you
Yes,
got is A into B. Okay, so this is the thing.
So we'll get one like in the rows. The first row is 1, 5, and 3. The second row is 2, 4, 3.
Exactly. So this will be your answer. The next one we come up with is properties of matrix multiplication. Okay. So the idea is properties of matrix multiplication. Okay. So if the first one is A into B is not necessary to be equals B into A. Is that clear?
Yes, sir.
Okay. The reason behind this, for example, if you can take this one, 2 into 2, but here what you have, 2 into 3, right?
Three.
If you just try to reverse, for example, you can do A into B because this and this is same. But if I reverse it, B into A, what it is 3 into 2 into 3, and it is 2 into 3, right? You can see this is not same. So here you can't even multiply them, right? Equality is not even a concern. You can't even multiply this, but you can do this, right?
Yes, sir.
So I can say this property holds good that AB should not be equals to B into B. That is fine. And this is called non-commutative law. Non-commutative law. Mean to say you can't rearrange by yourself the things.
Yes, sir.
The next one is associative. Okay. So what is associative? It is basically A, B, C. Will it be equals to the next thing?
Hmm.
A,
Yeah.
B, and C. Okay. This is what your associative law will look like in case of multiplication.
Yes, sir.
Understood? Okay. So then we come up as distributive law. Distributive law. Okay. What is that? A, B plus C. It is equals to AB plus BC. But you have to check out the order. You can't do it like you are going with the inside. So you have to go first. Okay. You can't do like you are going with AB and here you are going with CD. Understood?
Yes, sir. There should be AB plus AC, right?
Okay. Yeah. It should be AB plus AC. Fine.
Mm.
I just forward this. Okay. Here it will be for this is A case, this is B case. B plus C, A. Wherever it is written, you have to go with that. BA plus C. Right? You can see it is behind, so you have to put it behind. It was in the front, so you have to put it in the front. Clear?
Yes. So this is
Okay.
because multiplication is non-commutative. That's the reason.
Yeah, here the reason is multiplication is non-commutative.
Yes.
Okay. So that's the reason. So the next one we come up with um, transpose of matrix. Okay, the next property is also an important thing. Transpose. What we do in this case, we just flip the whole matrix by 90 degrees. Mean to say, if my A is something like 1, 2, 3, 4, 5, 6. So what will be the transpose of matrix? We show transpose as either this or A of P. Is that clear?
Okay. Yes, sir.
And I told I am going to what I can do. I am going to turn the whole thing by 90 degree, right?
Yes, sir.
It means whatever present here, you have to put it here. Understood? So this 1, 2, 3 can be represented in 1, 2, 3. Okay. Then this thing you have to represent like this. Okay. So 4, 5, 6. If you had something here also, you had to represent like this. Right? So it would come like this. Clear?
Yes, sir.
Basically you have to take one thing and do it by 90 degree, make it to 90 degree, take this, make it to 90 degree, and this is why it is just taking every row and turning it to 90 degree will result you the transpose of matrix. One, two,
So
three.
basically, here the first row becomes the first column, and the second.
Exactly, exactly. Row and columns get interchanged.
Yes, sir. Yeah, but it's not the other way around. Like you can't make the. Oh, it is the other way around also. Like the first
Yeah, it is
part
other
of
way around also, right? If I ask you what is the transpose of this, so if you see, if like here you have, you know this, right? You don't know from where you came, so it will become again same thing.
yes, sir. Yes, sir.
One
Got
four,
it.
2 5, 3 6. Got it?
Yes, sir.
So it is other way around is also working. So this is transpose. Okay. Now I'll just give you some properties for the transpose also. What is that? The first property is if you do A transpose and again do transpose, what you are going to get A, right?
Hey,
If you see carefully here also we check. This was A, I transposed it, and when I again transpose it, I got the same element back, right?
yes, sir.
Okay, so let's understand all this. The next one is K A times of transpose will be equals to A times K times of A transpose. Understood this part?
Yes, sir.
Basically, K is any constant element, right? K is constant element.
Yes, sir.
Okay. Now K don't have to go with any transpose because 5, 6, these are numbers, right? So when you transpose this element, for example, I'm having A as 1, 2, 3, 4 again. Okay, if I want to multiply it with, let's say I want it to multiply with K, a random element K. So I'll put it like this, okay? Now you're saying transpose it, whole thing.
Yes, sir.
Doesn't make sense like I can take K outside because it's a constant itself. You can do 1, 2, 3, 4. Again, the same thing, right? So it
Yes,
is K into A transpose.
got it, sir.
Keep outside. Okay. The next one is this thing A plus B transpose. It is not working as a power, it will come out as A dash plus B dash. Individual transpose of both. Clear?
Yes, sir.
And the last thing, A B to the dash. It comes out as A dash B dash. These four are the important properties. Okay? Wait, I missed you a little bit. I think it should be reverse. It should be B dash A dash. Understood? Any doubt you have?
So the dimensions are changing. The order is changing, right?
Which one? Which one?
Like when you transpose it, the like the order changes, right? Is that's the reason why it's like that?
Yeah, exactly.
Okay, sir.
Okay, because like this gives you different order, right?
Yes,
And
sir.
when I do this thing, I'll get another order when you transpose it. So
Transpose.
that's why we have to do it.
Yes,
Okay.
sir.
When you do this, you will change its order. Like when you put this whole thing, you will change its order. When you do this, change its order, and you will get the whatever order you need it here.
Yes, sir.
Clear?
Yes, sir.
So that's it. Now the next thing is some special type of matrix. Okay. Special matrices. What is the first one? That is symmetric matrix. Okay. Symmetric. What we meant by symmetric matrix? Symmetric is first of all, it is a kind of square matrix in which original matrix is equals to its transpose. Clear?
Hmm.
A square matrix where original matrix is equal to transpose. Understood?
Yes, sir.
Means let's say if I take this as an example, one, 2, 3, 2, 2, 3, 4, 5, 6, right? See, if I do transpose of it, 80, what I'm going to get? Again, same thing. Reverse it. 1, 2, 3. Reverse it. 2, 4, 5. Reverse it. 3, 5, 6. Right? If you see carefully, I have all the same thing. Both
Yes.
are same matrix. So I can say my A is nothing but symmetric in nature. Understood?
Yes, sir.
Any doubt you have here?
No, sir. Clear.
Clear. Okay. And the last one is skew symmetric matrix. Here what happens is your A is equals to minus 1 times of A transpose.
Yes.
Just one difference. Okay. A is equals to negative of your transpose. For example, I'll be having one matrix as what I can say A equals to 9, 2, minus 3, minus 2 and 3 over here you'll be having, and 0, 0, minus 7 and 7. Okay. If you do transpose, what you are going to get?
But the first element will not be negative, right?
Yeah, the first element will not be there.
So that
Okay,
also gets cancelled.
it should be 0. Okay, the idea is there. Skew symmetry, in case of skew symmetry, mostly this whatever I'm saying, this diagonal thing should comes out to be 0. Okay,
Zero. Yes, sir.
if it is not 0, so in that case, like you can okay, it should be 0. Ideally it should be 0 for an ideal skew matrix. It should come out to be 0 because when you even transpose it now, it is not going to change its order. Okay,
Yes.
diagonal remains same in their position. Clear?
Yes.
Okay,
But
apart from, okay, let's make it this. Now if you transpose it, what you are going to get?
minus of it.
0 to minus 3. Here your minus 2 is 0, 7, and here we'll be having 3
Three
minus
minus
7.
two.
Clear? You can see it is negative of whatever matrix you have.
Yes, sir.
And now,
No, sir. Clear.
by this we have completed a basic of this chapter. Understood?
Yes, sir.
Like basic overview of all the things which can have in this chapter.
Okay, sir.
All right. Um, okay, so let me check if some problems are there. Oh yeah, you can let me know your problems from the sets chapter so that we can resolve them, and you can try to solve these problems. Okay, problem on these topics.
Okay, sir.
I think let me check if some topics are left. I don't see any topics left. What is the syllabus? Okay, concept, notation, order, equality, transpose, type, simple properties, scalar multiplication, column, invertible matrices, and proof, application of matrix. Okay, some topics are left. We'll do that in the determinant portion. Okay, so that's the thing. Okay, mostly the chapter has been covered.
So did you get my question now? Like, it's showing me that I sent it, but
Like in notes, I don't have these. Like in this chat, I didn't get those.
chatting wise up. Okay, okay. In Zoom, are you saying, sir?
Yeah, in Zoom, I'm seeing. Here also, like WhatsApp, I didn't got. No one shared it to me.
No, no, I share it on WhatsApp, sir, but I'll share it on Zoom.
Okay, okay. Why is that where I can get share? Is there any option to share
Uh,
in the Wiser?
like,
Okay, maybe I got something. Okay, the first question is it?
yeah, yes, sir, that's right.
Just see this. Yeah, okay. So, what is this problem? The problem. Okay, so here they have given one equation to you, right?
Yes, sir.
On the basis of this equation, you have to figure out whether, like, what condition it satisfies.
Yeah,
So,
yes.
minus okay, 8 to the power n is Um, in this chapter, basically, you don't know the PNC, right? Permutation and combination.
No, sir.
Okay, that's the problem actually. I'll try to solve this.
So,
Okay.
will permutations and combinations take a lot of time?
Yeah, actually, that chapter takes a lot of time.
Okay.
Okay, it has many concepts. Okay, permutation and combination basic won't take a lot of time, but the permutation part. Okay, we'll
Application.
see. If it is required, we'll see. We'll just go with the easy chapters. Okay,
Okay, sir.
first. All right. So, what is the first equation if you see carefully? In this problem, can I can take? Okay, in the previous chapter, I'll take this part. I'll just paste that question here, and then we'll do.
Yes, sir.
Let it zoom a bit. I hope you can see the problem, right?
Yes, sir.
Okay. Let me increase the size a bit. If you see carefully, I have given an x as this thing, x and n minus 1 by n. Okay, and y is given as 49 n to the minus 1. Okay, so what I can do is, 8 can be represented at 1 plus 7. Okay,
Yes.
the reason behind doing this because I have 7 n. Okay, I want to remove it somehow. Okay,
Yes.
and my n belongs to all the natural numbers.
Yes, sir.
Just a second. Okay, base. I think this is not here. It is only till 7 minus 1. Okay, after that, it is just saying that, okay, this is the thing. Your n belongs to where? Okay,
Yes.
that's all. It is still here only. Minus 7 n minus 1. Okay, now the expansion, okay, the my binomial expansion of this comes out as, look, I'll just give you a hint. If you have somewhere write 1 plus, like a plus b times of n. Okay, what is this? What is basically you have to expand it, right? You know basic formula of a plus b, is
Yes,
it?
sir.
But here, if it is n, how you have to do? Just take c, put n over here, 0 over here. Understood this thing?
Yes, sir.
Okay. Start with anyone you can take. Either a you can take, either b you can take. Put the power to be 0, and for another one you have to put power n minus. Is that clear?
Yes, sir.
Basically, the formula is here it should be r, a to the power r, b to the power n minus r. Clear? Now
Yes.
you have to take this r from 0 to n. So when you take it from 0 to n, what you are going to get is nc0, a to the power 0, b to the power n, plus n to the power 1, a 1, b n minus 1. And so on till when you are going to get this becomes n, a becomes n, b becomes 0.
Yes, sir.
So here the same thing I am going to apply. Here my a is 1, so I can directly put this formula. N C 0, a is 1, so there's no significance of it. You have to just go with the b n. Okay, b instead of b I can put 7 to the power n plus nc1 7 to the power n minus 1, and so on till when you have to need ncn 7 to the power 0. Is that clear? Basically nothing.
Yes. NCN. Yes, sir.
Okay, minus 7 n minus. Any doubt you have?
No, sir. Clear.
Alright. Now whatever I have written, okay, that is the. Now what I should do? I need something to be calculated, but how I can do this? Any idea?
Mm, no, sir.
No. Okay. Let's see. This thing. Let's calculate this part. What is this? Not this actually. If you see, this is NCN, right?
Mm,
This before this, there's something called. Um, okay. NCN. Okay, I wrote it at NCN, right?
so
Wait.
that will be just one, right? Like even if we calculate it like how we. if we write 1 plus 7 into 1 plus 7 into 1 plus 7 like so many times, at the end
Exactly.
we get 1, right?
Yeah. So look, what will happen now? This will get removed. Okay. So you'll be having 7n plus nc whatever it is, s n to the power minus dot dot dot. Here you will be having something called um, plus 7 times of n plus ncn as 1. Look, this ncn has come out as 1 itself.
And yes,
Understood?
I
There
got that.
must be someone previous to it. And you have something like this, something like this. So you can see we have got cancelled it out. Is that clear?
Yes, sir.
So I have got something 7 to the power n plus nc1, 7 to the power n minus 1 till where you are going to get. If you see carefully here, my n goes to how much? Ncn. Before this, I must have Ncn minus 1. This before must what I should have?
And see minus 2.
Ncn minus 2, right?
Yes, sir.
So whatever I have to write it here as Ncn minus 2, 7 to the power what? N minus 2.
Yes, sir.
Clear this thing? Okay, let's see y equation. If you see in y, it is given as 49 minus n minus 1. Okay, it is saying 49 n minus 1. Is that fine?
Yes, sir.
I have to figure out what can be the maximum value of n. Okay, like what can be the maximum value of x can go if I take it 1, 2, 0, and something like that.
Mm.
Okay, so if I try to figure out, extract out 7 to the power 2 out of this, then I can think of this part, right?
Yes, sir.
Okay, let's take 7 to the power 2 also. So what I'll left with? I'll left with 7n minus 2, because 2 power will get neglected. Okay, so nc1
Sir,
7.
this is a doubt, sir, here. In NCN minus 2, 7 power 2 it should be, right? Not n minus 2.
um
Like the
Here,
answer, yeah.
no, no, if yeah, and it is n minus 2, right? Wait, what I did?
And
Yeah, it is n minus 2. Okay.
so it would be 7 square, right?
Yeah, wait. Yeah, let me check. Look, the last part was how much? It was 7 to the power n, right? Just before will be 7 to the power n minus. Okay, I think I made a mistake over there. That was n minus n. It will n minus n minus 1. So what I'll be having right now is n minus 2. Okay, so this n will get cancelled. You will be having 2 on.
Yes, sir.
Okay, I'll just move this. So it will become cn 2, and here you will be having
So, no,
7
no.
to the power 2.
So C and n minus 2 only, sir. But it will
No,
be,
no.
because like if you
Okay,
see,
okay. I'm doing this and this right. So it will be n minus 2. That is fine. Okay.
yes, sir.
So remove it for now. N minus 2. And here we'll be having this. Clear?
Yes, sir. Clear, sir.
Okay. So if I just move further till at the end of the day, I'll be having n c this. And this 2 is removed. Okay.
Yes, sir.
Right. So to have this condition, to satisfy this condition, whatever I have taken, my n should be greater than 2. This is one thing I know,
Yes, sir.
right? Because if my n is less than 1, if my n comes out less than 1, so I will not be able to take 7 to like what is this, uh, s-
Yeah.
7 k power 2 outside, right?
Yes, sir.
So I got to know that n will greater than equals to 1, like always greater than 1 for this condition. No, so always greater than 2 or equals to, it must be equals to 2 or should be equals to or should be greater than 2.
Greater than
This
2.
is one
Yes.
thing. Okay, so I can say it contains some of the multiple of 49. Is it?
Yes, sir.
Okay. If
Sir, and any multiple of 49, we can represent it as n minus 1, like a
yeah,
49 to n minus 1. So,
so
like
look,
this,
yeah, okay,
so you're saying that this complex equation that we got would be like some subset of the 49 into n minus 1.
exactly. The reason behind this, if you see it is 49 multiplied by something, but
Yes,
the condition is here n should be greater than 2. Okay,
yes, sir.
greater than. But here, if you see, even if my n goes to 1, then still I am having a equal value, right? I can get 0.
Yes, sir.
Okay, so I can say this value is applicable for more range, like it has one more extra range, that is n key value 1. Here the condition is n key value 2. So I can say here the possibility of n is less. For example, in the first case, what is the first case? Yeah, in the first x, my n is going from 2 to like something infinity, but in
Yes.
y case I am getting it from 1, right? So can I say this 2 portion is already covered here?
Yes, sir.
So X is subset of Y. I can say this part.
Yes, sir. I got it,
Okay,
sir.
that's the thing. It's not a perfect subset, so I can say this set. Or you can say Y is a superset of X.
Yes, sir.
Understood? Okay. Any doubt here?
No, sir. Yes, sir.
Alright. So this is all for the today's class. Okay. Try to solve the problem on the basis of this. If you have any doubt, we will discuss that in the next class when we
Okay,
take
sir.
it. Yeah.
So next
Uh,
class tomorrow or no?
uh, Tomorrow, look. Okay, I'll be free. So if you want, you
No,
can
no.
tell me.
Tomorrow
Okay.
is Sunday. Never mind, sir. Monday, right?
Yeah, tomorrow Sundays. I'm just saying, like I'll be free. So if you want, you can take the class because in upcoming days I'll be going, like I'll be traveling 2 days. So on those 2 days I won't be able to take classes. Okay.
Okay, sir.
So I'm not saying for 11 p.m. Whatever time in a whole day you can tell me. But yeah, before, like tell in the morning itself. Okay, so that I can plan accordingly.
Okay, sir. Yes, sir. Tomorrow evening is fine, sir, for you?
Yeah, anytime you can tell, but just plan accordingly so that I don't have to get surprised that I have to take class.
Yeah, yes. Yes, sir. Okay, sir.
That's all for the today's class. We'll meet in the next session. Goodbye.
Thank you.